Hi guys! Now we have an odometry module left to set it up so we can use it. This is MIPR that I made in a previous video. I have added these 4 standoffs that the odometry module will be mounted to. The pins on the HC05 will need to be bent by 90 degrees so they look like this, allowing us to add the odometry module with the HC05 inserted. I'm going to mount MIPR on his box so I can carry out the calibration. If you don't have a box you can hold it instead. These are the wheels with the added stickers. Now I will screw the odometry module onto MIPR. Ensure that the TCR-T5000 sensors are at the bottom of the module. This is what we are aiming for. Looking through the holes in the wheel you can see the infrared LED. This infrared light will be reflected from the stickers and we can use this data to calculate MIPR's speed and distance traveled. For it to work the sensor needs to be aligned. This must be done using the method shown in this video. Now connect the odometry module to the auxiliary connector. Please note that ground and 5 volts are the other way around on the odometry module. Use pins A6 and A7 on the auxiliary connector for the data inputs. Now everything's connected, we will add a battery and upload some code. Go to elite.uk and navigate to this tutorial, a link is underneath this video. Download the zip file under the heading calibration code download. Extract the files and you should see what's on the screen. Open one of the Arduino files and Arduino IDE will load with the code displayed. Then open telemetry.jar and set the screen up as I have. Upload the code to MIPR. Once uploaded, open the serial monitor. Once the serial monitor has opened and is connected to MIPR, type a capital letter C and press enter. This will run the calibration routine. The mean left and mean right figures must be between 4 and 600 for the module to function correctly. If they are out of this range, gently push the sensor either up or down and repeat the calibration routine until you can get them in spec. If you cannot get them in spec, then try using different more reflective stickers or move the sensors closer to the wheels. Once this is done, type a capital P and press enter, then type the number 1 and press enter. This will restart MIPR with motors moving forwards at half speed. Now click on Open Layout in the telemetry application and select the text file included in the zip archive. The program will try to connect to MIPR and probably fail. Select the correct baud rate and the correct COM port and press connect. The telemetry program will now connect to MIPR. Once connected, you will see a pulse train for left and right wheel. The pulse train will show the raw analog signal from the sensors and a digitized sample of the signal. In the example that I'm showing here, the right wheel is calibrated properly but the left wheel isn't. If you look, you will notice that the square wave created by the left wheel's rotation does not represent the analog waveform from the raw signal. For the odometry module to work, this must be corrected. To correct this, I used different stickers and repeated the calibration routine. Now when I run the routine, I get better figures. Let's look at the pulse train to see how it looks. As you can see, the left and right analog signals are being digitized accurately. We will use the square waves to calculate the robot's speed and distance traveled. To ensure that the wheels don't come loose, I'm going to hot glue them in place. The calibration figures will be saved to the EEPROM, so you won't need to repeat the routine. However, if you start to get inaccurate odometry data or the robot starts to act erratically, you will need to rerun the calibration routine and perhaps change the stickers or reposition the sensors. Thanks for watching, and I will see you next time.